So today, as you've seen on the flyer, the topic of today is called DevSecOps in Practice. And before I just start, talking more about this project, this topic, I'm just gonna try to give you a very short story of my own experience related to this, related to the topic that we're going to talk at the moment. So several years ago, I was just working for a company, and I was just leading a team of software engineers that were working on this massive application. And we spent a lot of the month, weeks, and days developing this application because we were just on rush to get this application to go on the production. But and we actually managed to finish almost all the work that was intended on this software. But the funny thing happened before we got to the launch. Actually, the people who knows there is nothing really marvelous as actually launching a product. So, but before we went into launching the product, I just realized a lot of vulnerabilities I haven't recognized before, and I was really afraid that if I let this go into the production, it's going to cause a lot of harm than good. So in those few days that I just had, I spent a lot of the time, I spent a lot of the hours just trying to fix these vulnerabilities. And if I would not get lucky enough, I would find that I just need to revamp the whole feature so that I bring the new version, which is really secured. But this was really nerve-wracking. Yeah, so, but actually, I just want to let you know, you can't be surprised about this because actually this is how we see the traditional software projects used to be tested. Most of the things regarding the security considerations used to come at first when the software was about to go into the production. And this is where DevSecOps comes in. I was expecting a round of applause. Yeah, so in DevSecOps, we are just making sure that in every phase of software development lifecycle, every part is compliant with security practice. And we just make sure that each and every deliverable feature is just not going to cause any vulnerability when it goes into the production. And during this moment, during this tech talk, we're just going to focus on the part of the CI/CD pipeline. How can we make sure that the part of the CI/CD pipeline is just compliant with the security practice and also security regulations? So I'm not going to say a lot about this topic because we have a distinguished speaker today who is going to lead us through this. And allow me to introduce the speaker of today. I would say I first met the speaker when he was training me about the security competition I was going to attend. Maybe he don't remember, but he was training me about this security competition that I was going to attend. But he not only just possesses these skills of teaching, but he's also a security expert. He's a real security engineer here at Irembo with over 5 years of experience. But not only to that, he's also a graduate in information and technology from the CMU, Carnegie Mellon University. And he also holds an undergraduate degree in applied mathematics and computer science at JKUAT, which is Jomo Kenyatta University of Agriculture and Technology. He also holds a certification at the ICTU, and his skills include vulnerability assessment, penetration testing, network security, software, and web development. Who is this person? Ladies and gentlemen, allow me to welcome with a round of applause, Geoffrey Duarte Jogo, presenting the art of
That's quite an introduction for a small person as I am. Thank you very much. I do appreciate it. And good afternoon. How is everyone doing? Alright, awesome. So I think I will go directly to the presentation and then the demo and then. Alright, awesome. Okay. So I want to give us a snapshot or an overview of what DevSecOps is, and then we are going, according to the title, it's DevSecOps in practice. So we have prepared for you a hands-on demo where you will see these tools actually work, because we've realized that most of the talks that we have out here and online, they're very superficial. You never see the actual thing in practice. So today we're going to see some of these tools in practice, and then we're going to take on some questions. All right. How's the visibility of the screen? All right, awesome. So today's agenda is very brief. It's just an intro to DevSecOps, and then we're going to go to the hands-on demo. So we're going directly into what DevSecOps is. So I think most of us have heard of DevOps, right? Who among us is a DevOps engineer or interacts with DevOps day to day? Amazing, at least we have a couple of DevOps, but you see, nobody cares, or nobody knows too much about the DevSecOps, hence the conversation. So basically, DevSecOps is the integration of security practices in the software delivery model of the DevOps part of it. So from development all the way to the operations part. Then, when it comes to DevSecOps, now security becomes a responsibility for everyone. In the traditional approach, security just belongs to the security engineers or the application security engineers. But now in this approach, everyone is responsible, from the developers, from the operations teams, and the security team. So in a nutshell, maybe the difference between DevOps and DevSecOps is the introduction of security in the DevOps part of it. Also, if you step maybe one more step behind or back, DevOps is the combination of developers and operations. Developers are the people who they're the ones who are releasing the software, and then operations are the guys who ensure uptime, all scalability and all those kind of things. But those two people were merged because of the back and forth. Someone just gives you software to release, and they have not even told you how many people will be using it. You don't even understand the architecture behind it. That's where the DevOps term was coined. But now, after the DevOps have released software, then now that's where the security guys used to come in play. So now security used to be one step behind, or many steps behind, basically. Hence, the coinage of the word DevSecOps. So DevSecOps comes with one goal. The goal is not to slow down releases. I think I've heard the conspiracy or some theories where people say DevSecOps or security are a hindrance. They are there to slow down releases. But in real sense, the goal is to incorporate security in all phases of software development lifecycle. So when you see people gathering security requirements, that's where the DevSecOps starts. Then it goes all the way to after deployment, when people are doing the monitoring and the maintenance of the application. So in this case, and the reason why we have DevSecOps and how we do the incorporation of security in all phases is having security at the source. So from the requirements to the development to the CI, the continuous integration to the continuous deployment. And one of the things that we do is to automate repetitive tasks. I think the security engineers, the SAST is security application, static application security testing, and SCA is software composition analysis. So the software composition analysis comes to play when you're dealing with the open source projects. Most of us build projects based on the dependencies that are, the dependencies, or how do we call them in Node.js? Packages. The packages that have been built by other people, you just import them. But are you sure that these guys are actually solid? Do you know the vulnerabilities in them? Same case to when you're building on a Docker container, do you know the vulnerabilities on that image itself? So that's where the software composition analysis comes to play. The static application security testing, we already have known vulnerabilities. For example, if someone has a query that is not parameterized, that can lead to SQL injection. But at what point does the security engineer come to play to tell you that we have a potential SQL injection even before the code goes to production? That's where now the SAST tools come to play. And that's it. One does not simply write great code at first time. You write some code, it goes in the CI, it's scanned, you get some output, you implement, you get some feedback, you use the feedback to improve your code, and at last you write some great code. Awesome. So some of the benefits is to avoid this. As he said, this is a very good kit, but it serves no purpose.
you can pass by anywhere. So that's the same thing that we do. So we area identification of vulnerabilities on the CI. Once you push code, it's scanned, you get the feedback. You try to build to make a release. The container is scanned, and you're told, it has so many vulnerabilities. Also, we reduce cost and help in faster delivery of software. As he said, I think his story makes a lot of sense, where you've already built your software, it's ready to go live, only for you to realize in the last minute that there are a lot of changes that you have to do. So just imagine building software for 6 months, and then on the last day, you realize that the dependencies you're using are very vulnerable and cannot go live. You have to go back and rewrite the code. We offer transparency. DevSecOps offers transparency. So this is shifting left. I'm not sure whether you guys have heard of the term shifting left. So this is security being brought back to the developers and to the ops people. So through that, because we are all using the same tools, you're able to get the feedback instantly. That's the transparency that is there. And also for the security teams out there, we are able to work even faster. If the thing is automated, I don't have to be following up on why did you push these and all that. All right, awesome. So yeah, there we are for the demo. Maybe do we have any questions as to DevSecOps, or questions will come later?
No worries, we can just get the questions.
Okay.
If there is any question regarding the presentation or anything else about the DevSecOps, yeah, you can ask.
I think no questions means contentment. Oh.
Or if there is a question. Yes, you can ask.
Right, thanks everyone, and especially for the nice presentation you've shown us. My name is Musigwa Pacific, and I recently joined as a software engineer, which means I'll also have to learn how the security team and developers integrate to release secure software. And my question lies onto that specific part. I'd like to know what are the recommended practices for developers to minimize, the back and forth problems that can be shipped for their code. Like, how can we minimize the cost of going back and forth through development security? How can we? What are the practices that we can adopt to make sure to minimize that time spent into the process?
Maybe to respond to that, the simplest answer is usually defensive programming. By defensive programming, this is where you're observing the secure coding standards. I think I gave an example of non-parameterized queries. You can write prepared queries for that, for that example. True. When you're writing your APIs and you have to fetch an entire row, but in real sense, what is needed in the front end is just the 2 columns, not the actual row, because that now brings about information leakage. So basically, by incorporating the defensive programming, and also now the DevSecOps part, where you have the security requirements beforehand, that definitely in a lot of ways stops the back and forth. But I think as a helper, the tools come to help, the automation of these tools. So if these tools are already set in a manner where you push your code and you get your feedback immediately, that will be faster than you pushing code to production, and then that's when we are coming back to tell you that whatever you did, you need to revert. So I think that's where the DevSecOps part will come to play. The tools themselves. All right, awesome. So with us, we have prepared a short, long demo. So we are going to showcase the various things that we have said. So, we talked about static application security testing. We are going to introduce you to one of the tools. We spoke about software composition analysis. You want to understand, the bill of materials in your software. And then we are going to look at a final tool where now we'll be scanning the Docker containers to see whether any container has any vulnerabilities. Is that fine? Okay, awesome. So, and all these tools, other than the SAST tool, all of them are open source. So we try focusing on open source so that I think they're free, and it's a very good starting point so that you can get enough data to convince your management that you'll need something greater. All right, awesome. So we're going to start with the SAST. So I'm going to set up Sonar Cloud. What we have here is a Spring Boot application. So this is just, I think on a normal day, when the developers write their code, our CI tool here is GitHub Actions. So, you push your code, there's a branch, you merge it, you create a pull request. I think most of us are aware of the build. When you push code, the build has to first run to see whether you've broken anything. And then now once the build, I think that's the YAML file for the build that we're going to use today. Once the build is done, most of us have a different file. It's a release file. I think that's just a normal release file that will build your Docker container, the package, and push it to Docker Hub, so that the person who is deploying will just go to Docker Hub, pull the container, and all that. But as you can see so far, what we've done in this demo is we don't have any security checks. So whatever you push goes directly either to the main branch or to whatever branch that you've created. When you create the release, nothing again is checked. So we want to incorporate those checks here. Our first tool that we're going to use is SonarCube. So the open source version of it is SonarCube. This tool is already configured by the researchers themselves to identify some of the gaps or the vulnerabilities in Java code, C code, Go code, whichever kind of language that you have. All right, so we are going to create, it's just analyzing. I just want to show you how easy it is to incorporate DevSecOps in your pipelines. Let me select, I think it's DevSecOps. That's my repo. That's the one that I want to set up. I want to create the project. So incorporating a SAST is okay, it's doing its thing. All right, I think we didn't import it right. So my projects it's analysis in progress. Okay, so we're still not using. So what we have done so far, I had already connected the two applications. This is the automated analysis. Just you can see how easy it was. I just went to the UI, clicked on SonarCube. It's a public repo. That's why we didn't have to import a lot of credentials here and there. So this is the initial analysis. So what we're going to do now is we are going to configure a YAML file, a workflow rather, such that whenever code is pushed, or whenever changes, or whenever pull request is made, the code is first scanned before it's merged, or before the other services are, before everything else is done. So to do that, I had already prepared the script. So on our workflow, I'll just add another workflow. Create new file, Sonar. Okay, so I'll just copy paste these instead of writing it from scratch. So GitHub Actions have a marketplace. So in case you have any difficulties using GitHub Actions, you can just Google their marketplace and they will give you everything that you need. So I'll just go directly to my work. Okay. Let me just search for the repo. So I had pre-configured these. I'll just take the file as is. Come to a file right there. So what I'm supposed to change at this point, okay, all these I got from the documentation. There's not too much thinking. So the tool is out there, it's open. Then we have enough documentation. So all I will change maybe is the project key. I don't know whether you can see the line right here, the project key. You can also change the organization, because this is a different organization now, because this is a totally different example. And yeah, everything else stays aligned. So what you will have at the end of the day is this. So whenever someone makes a change, you get your report. You get your report on whether there is any vulnerabilities. You get reports on the reliability of the code. You get reports on the security hotspots. So these are not actual vulnerabilities, but these are potential. They can lead to. That's why they're called hotspots. So if you want to know the details, you just select that. And as you can see, we have an issue. So it will give you this, and then it gives you how to fix it. So if you want to learn how to fix it, it gives you the actual implementation. So as a security engineer or as a dev, as a security engineer, it reduces one thing for you. Whenever you're doing manual code review, you first start with the automated one. The automated one points you directly to where you need to focus your attention on. Instead of going through the line one by one, you start with the automated, which is this. Then now the other, or any other issues that you want to do, you will use, this one will give you, okay, it will point you to the security hotspots, it will point you to the vulnerabilities, then now you're able to do your analysis faster. You can see how it makes it easier for security engineers. It makes us go faster. And also for developers, if you push code to this guy will scan that code. It will scan that code and give you feedback immediately. So I'm rushing through. I had been given 15 minutes and they're almost over. So I think I'll just go to this one here instead of redoing the whole thing. The other tool that we wanted to introduce is OWASP dependency. So you realize that you're importing dependencies. So example is when you're using Spring Boot, you will use Maven or Maven dependencies. You don't know the order, okay, you will know the order based on the documentation, but you don't know exactly whether we have any vulnerabilities in here. So this, the OWASP dependency checker comes to do that for you. It will take the dependency, do the assessment for you, and give you a report on whether or not that dependency that you're using is vulnerable, and it will also tell you how to fix it. You need to upgrade to version ABC. So an example of this is, I had already ran this beforehand rather. So I'll just come right there and grab one. So you can see right here, the way I've configured, it's an open source project. We are rushing through, I'll give you the link to the project. The way I've configured it is after it does the running, it saves your report there. So anyone, anywhere who has access to this organization can come right here and download the report. If you just click on that, it should automatically download the report. Yeah, as you can see, it has downloaded the report for us. And just to give you a glance of how the report looks like, it's downloads, and then we search for dependency. We'll open that. So that's how the report looks like. So I'm not sure whether you can see that. So it will tell you the dependency. This is the dependency, the vulnerability, the package definitely now from Maven, the severity. Is it a high risk? Is it a critical one? The CVE, CVE is automatically calculated for you. And if you want to dig deeper, you just click on it. It will give you even more details on it. And maybe lastly, if you just click on the package, okay, it takes you directly to the Maven repo. But it should tell you also where or which version that is not vulnerable. So in Spring Boot, when you are doing the POM file, you have to specify the version. So you just go there and update it it will automatically fix that problem. So that's part of the software bill of materials, software composition analysis. Lastly, we have one more example, which is now, okay, you have already scanned your code, you have already scanned your dependencies. What about this Docker image that you're using? How do you know whether it's susceptible to any vulnerabilities or not? So for that, we use an open source tool, again, called Trivi. It's open source, you can use it anyhow you feel like. So again, I've also configured it in a manner where it gives you the report, something that you can download and share with anyone else. So to view this, we'll just download it. So also just maybe to give you a snapshot of it. So I have configured it to just capture the critical and high, depending on your organization policies and everything else. You can say that nothing should go to production if it has a high or a critical rating. Some people have those kind of rules, so you can easily customize them on this platform. And since you've downloaded the report, I'll just open it right here, and we'll be able to see the format. So I will open it with VS Code and zoom in. You can see the kind of report that is in there. So this is Ubuntu 20.04. And you can see the kind of vulnerabilities that it has. So you who is using an image that was developed or created by someone else, how many vulnerabilities are you pushing to your production environment? You can easily use this tool, and it will give you this kind of report. So we've covered the software, the SAST, we have covered the SCA for the code level, and we've also covered the SCA for the Docker environments. So I think for the demo, in terms of demo, that's that.
All right. Another round of applause, please. Thank you very much, Geoffrey. That was really informative and great. So I just want to ask you some of the questions about the presentation. And actually, the first question I just want to ask, we just want to look about the world before DevSecOps comes in, right? So we've talked about some of the traditional software projects, some of the challenges they used to face before DevSecOps comes in. So what do you think, what are some of these lists, what are some of these challenges? We want them what are these, what are these lists of not integrating DevSecOps in our software projects?
Awesome. I think that's a great question. So as you've seen, or as I mentioned earlier, DevSecOps is not just on the CI/CD. It goes even before that. And there's a lot of things that you can do manually, and there's a lot of things that you can do automatically, and there's a lot of things that you can miss if you just trust your eyes. So I think there's an example where several organizations, you just realize that someone pushed credentials that they in plain text. One, when it comes to zero trust, something that we're trying to enforce here. If all your developers have access to your code, and if you push things in clear text, then only the developers will have access to all their credentials. So you can already see an issue there. But if you have DevSecOps in place, we have tools, open source tools again, that you can incorporate also on your IDE level. It doesn't have to go all the way to the CI/CD. On the IDE level, you can use something like SemGrep or TravelHawk. It will automatically tell you that you have credentials in plain text in your source code, and you don't have to wait until someone raises that or misuses that. Also, I think DevSecOps comes into play again when we are gathering security requirements, because it's in the SDLC. So you find that in the later stages, that's when you realize you're supposed to be compliant. You're supposed to be compliant with the data privacy and protection law, but you had not done the policy decomposition to identify the security requirements that pushes you to that kind of, compliance. Yes. Let's say you're building a fintech program. After pushing it to production, that's when you realize that the password should be 14 characters to 64 characters. So you have to redo that. So you see the cost. You'll have to, again, get one developer to rewrite the code. QA have to rerun the runs or the checks. The DevOps people have to dedicate time to push that. Your CX or your customer experience people have to monitor the application to see whether any changes are affecting anything. So you can see the cost goes again back. So by lack of DevSecOps, it brings about cost issues. I think I can just summarize it in that.
That's great. So, in that answer, you've talked about there are some of the security tools that are open source. But I know many people here are just wondering what are some of these tools we are actually using here at Irembo? I hope that's not social engineering.
I think the concept of security by obscurity tells me I should disclose everything and let you guys do your best, but okay, don't do your best. All right, so some of the tools, actually all the tools that I've demoed here today, they are in use here. So on our first level, we do use Sonar Cloud. And in this case, we use Sonar Cloud in a way where if it detects a vulnerability, it stops the build. So I don't have to come in place the application security engineers don't have to come and review the report to tell you to redo your thing. You can see the program, one of our managers smiling because he knows the pain it causes. Then another tool that we use to complement Sonar Cloud, we use SonarQube. So this is where the application security engineer will run this code on his laptop, and then I'll compare the results. You want to complement, it's a tool, it might miss something, so you want to complement it with another tool. Same case to the OWASP dependency checker. We do use a tool called New Relic. New Relic has the capabilities to tell you which dependencies are vulnerable, but also to complement it, we use OWASP dependency checker. Then on one of our products, we have several. We do use Trivi to do the scanning of our Docker containers. Then on top of that, we have a tool, platformization. This is a very big concept that is going on where you're taking multiple tools, combining them into one platform. There's a tool called Kube Clarity. It's an open source tool. It does everything that we've done here other than the SAST. So it will tell you which dependencies are vulnerable and which components in your Docker containers are vulnerable. But that one is more of it waits until you push everything to that environment so that it tells you that. So it's more reactive than the rest of the two applications. Other tools we use Kubernetes a lot. So to avoid people from pushing passwords and usernames, passwords majorly in plain text, we use KubeSeal. So this is where you are sealing a secret. Basically, you have a key, you seal the secret, you give the key to the application, only the application can unseal the key. So if you get into an environment, you will see sealed keys that you can't use. So that's also something else that we use. Then we also have a couple of monitoring tools. We have OAuth. The OAuth tells you which, the WAF will definitely block anything that comes to play, but it will also tell you the kind of data that you're collecting on each and every API. And it used to tell us that, I think there's something else it does, once I recall, I will let you know. So those are some of the tools that we are currently using.
Thank you very much. Yes, so now open to the audience. Let me see if there are some people who have the question regarding the presentation or anything else you may need to ask about this topic. Yeah. So are there some 3 questions? Oh yes. Yeah. Thank you, sir.
Thanks again. We spoke about especially trying to secure or to adopt secure methods while using things like scanning through the code base dependencies. Do we have, or have you ever faced some other types of security vulnerabilities that may probably come from an approach that someone has taken to implement something other than any other types of vulnerabilities other than the dependencies, vulnerable dependencies, exposing keys and so on?
Yes. I think that's a very good question because vulnerabilities arise from many things. And an example that we have ever gotten here is, we had the data privacy and protection law that we had to be compliant with, where we have to uphold the CIA, the confidentiality, integrity, availability of data, such that You only access your own data. You only view data that you are allowed to view, and you have to consent to. You have to consent when someone is seeing your data. I think if you've reviewed our platform as of now, you cannot view someone else's information without getting an OTP. So that's something that we had. That's a vulnerability that is there. In real sense, people would say that's not a vulnerability, but when you look at it, that's information leakage, because it used to occur that if I have your bill ID, I'll see your details. I'll even maybe see your certificate in there. I'll see where you're from. But as we speak, that has already been fixed, where for you to view all those kind of data, you need an OTP, and the OTP will be sent to the person who applied for that service. So that's a vulnerability that came up because we prioritized. It's a fight that goes on here. We prioritized customer experience and neglected, because if I don't need an OTP, it becomes easier to use the platform. But if I have to wait for an OTP, it becomes partially harder to use the application. So you see, we went for usability and kind of neglected security. But now we had to we had to go through the cost. Developers had to do their thing. Customer experience had to do their thing. All the teams were involved, and that's currently fixed.
All right, yes, question here. Yes.
I'm by the names of Pratice. I wanted to ask one question. How do you mitigate the risk when one of the project dependencies is the one you needed the most, and yet it is vulnerable to some risk and you can't find an alternative solution to that? How do you manage that risk? Do you allow it to proceed, or? Thank you.
That's really interesting.
That's a great question. So you have a dependency that you really need on your application, but it's vulnerable. Sorry? Oh, I see. So for that, definitely the risk, some of the things that the application or the security guys do, we advise. Security is, again, one of the quotes that I love from the NCSA CEO was, the solution should never be bigger than the problem. So if the solution is to remove the application from being used, it's already bigger than the problem. So that's one of the things that we need to understand. So you can't just take down an application because of that, but you also look at how exploitable is it. So if you look at how vulnerabilities are rated from the CVE, I think they look at 7 categories. One, what kind of access do I need to exploit that vulnerability? Do I need to maybe be logged in? Do I need to have an actuator exposed? So you first look at that. Then you look at how easy is it to exploit. So if you realize that anyone from anywhere can exploit it, okay, again, how easy is it to exploit? Because if you look at some of the cryptographic vulnerabilities, such as the heartbeat SSL vulnerability, to break that will take some time. So how easy is it to exploit? Then again, you look at the impact. So something like Log4j, if we should bring that back to the conversation, in December, I think 2023, it was so easy to exploit. It was very easy to exploit, and the impact was very big because someone will take over your entire servers just because of the remote code execution it brought. So something like that you have to fix. Basically, as an organization, you have to sit down and understand, is this a risk we can accept? Is this a risk we can mitigate? Or is this, can we build other processes around it to protect it? I don't know if that makes sense. It's like having an egg, but you build a metallic box such that nobody can get to the egg. Can you do that? In as much as that introduces technical debt, in the meantime, it will help you as you look for more solutions. Yeah.
Can I speak? And I think,
in addition to that, sometimes if you are using a dependency and that dependency is using another dependency that has a vulnerability issue, I think some projects actually allow you to override that dependency that you're using. For example, let's say you're using on Next.js but Next.js depends on another library, which is vulnerable. So you could patch that library, get a version that's patched, and actually install it in your project, and it will override the one that Next.js is using.
I see.
Yeah.
Yep.
Thank you very much for contribution. Yes.
Another question.
I see there.
There's also a question up there. And
Okay.
Yeah, it's just an additional contribution. My name is Peter, engineering manager at Irembo. Just to say, this guy, you see, this man, usually when it happens, we have just an emergency room and we have to fix it at Irembo, basically. So, and now you can have a different way of fixing it. You can replace based on the version. If you have the main dependency, something is depending on something else, and the vulnerability is at 2 or 3 level, you find a way to fix it at that level. But in the meantime, we try to use as much as possible tools that are open source, so that you can have a lot of possibility to fix them before. Yeah. But I have one question for you. As you have mentioned, for us, when we are, us as a developer, we can see the security activity as activity that are slowing us down during the full implementation, especially when we are rushing for the first delivery. My question for you is, from your point of view, how can we approach it? Do we have some kind of set of tools or something that we can set, or a standard of things that we can set in the beginning of the project really quickly, so that the development team can rely on it? Or, but for your point of view, what will be the best approach?
yeah, thanks. I think that's very true. In some sense, if you find a project that is running, then you inject security in it, the cadence will first slow down as they're trying to fix some of the issues that have been brought up before it catches up with, before they clear the technical debt and everything and catch up with the standards. I think that's expected, true? So as you said, I think these tools that we've demoed here, if they could be at the inception of the project. So for example, when the CI/CD guys, or when the CI/CD is getting set up, we set all the automated tools as Sonar Cloud, New Relic, Sonar OWASP, Dependency Checker, Trivi, and everything else, such that your first push to that project or to that repo, you actually get the feedback immediately. At that point, you might have 6, 7 things to fix. But if I come to your project 1 year later, you won't have 6 things to fix. You might have 6 times 12, 72 things to fix. You can see how this the cadence will again will be affected. So I think if at the beginning of the project, if the architect, the software architect, brings about the application security engineer, then everything will run smoothly. That will be my view.
All right, that's great. So we're going to take more questions after.
Sure.
Yeah. We can take more questions after. We have another time, for asking the questions. All right, so I just have more questions for you. I want the question from the audience, please. Don't be surprised. All right. So one of the questions I just have for you here, this is more sounding of more of security, right? Maybe some developers might say that, okay, you are just taking us more into security, right? Well, we are just software engineers, right? So, and I was just wondering, is there any collaboration between software engineers, DevOps, security teams, to ensure the security of the software is observed in the context of DevSecOps?
there's definitely an opportunity for everything. So these three people or these three divisions can definitely collaborate, not just on the CI/CD perspective, but one, I think we spoke about the requirements at the start. Then now we have the technical designs. Some of the vulnerabilities that we've seen and some of the major vulnerabilities that have been there have been based on like broken level access. I think we have Bola and Bofa for them who want to go and research on that. This is where the logic, how the flow of your logic can be broken easily. So I think if you involve security engineers on that level, where they can even first review the logic of everything else before you even start writing your code, it saves you more time than when you've already written your code and someone breaks it and you have to rewrite the entire code. That's one point of where people can actually collaborate. The other point where you can even collaborate with the ops people or the operation people. So these are the people who are involved with your deployment. Let's say someone takes a server, configures it, and deploys the application. Later on, when you come and run maybe a security tool or you do the manual application or the manual testing, you realize that you have some very critical vulnerabilities in there that can only be fixed if they upgrade the operating system that they have. In real sense, if they had invited you before they did their whole deployment and moved on or moved that far, you'll have closed these gaps and they don't have to redo their work. So you can see how the collaboration will go. So the collaboration will start with the developers, the developers aspect of it. Then with the DevOps people, when they're setting up their CI/CD, that's when all these tools based on what you need, they will be incorporated. And even when the configurations are being done on the server level, if you invited at the very beginning where you can juxtapose what they have with the CIS controls or with the CIS Center of Information Security recommendations, you're able to patch things at an earlier stage than redoing the actual work. I think that will be my line of collaboration from the DevSecOps perspective, from the security perspective with the developers and the ops people.
All right. So in other words, there should be a shared responsibility.
Yes, security belongs to everyone because we have the rule of segregation of duties. If security engineer should not be the one who is patching it. Otherwise, if you tell me to move this chair from here to there, and I'm the one who is supposed to award myself marks, I might just award myself marks by saying that wherever it is, it's very comfortable. I'll say like there is a hole wherever there's no, whilst there's no hole. I don't know if you can see that. If my responsibility is to find and fix, then I might say I've not found anything so that I don't have to fix it. So basically that's why the collaboration has to be there. We have the gate guards who are the security engineers, and then we have the implementers who will be the DevOps, the system engineers or system admins, network engineers, and all that.
All right, that's great actually. So there is a common phrase I would say in developers when they just say that if my code works, don't touch it, right? And at times you might find that I've just copied those codes from Stack Overflow. I don't understand how they work. So, but at times, as we've just had, it might contain some vulnerabilities, right? So that's why we should also involve security teams to check that code and also take that responsibility to yourself. Yeah, so another question I just want to ask you, it's like from the article I just read last time, recently, I was really fascinated where it was actually talking about that actually C and C++ are actually the major languages that exposes some of the memory leakage issues. And I was really fascinated because I just use C++ very frequently in competitive programming. And I was, this showed me how, like in security, you need to keep yourself updating yourself. And I was just wanted to ask, what are some of the approaches you use to keep yourself updated to the latest trend, latest, threats in security? What are some of these approaches you use?
Yeah, that's true. I think vulnerabilities are forever popping. If there is one thing that we have to agree on is they will continue to pop. One very strong thing today will be very vulnerable tomorrow. or even maybe in the next second, you never know. So one of the things that I do personally is I rely on newsletters like articles. So we have some platforms where people just publish. And then we also have the NVDA database. So whenever a critical vulnerability is found, or whenever vulnerabilities are found, or new vulnerabilities are found, they have to be published. So if you go to the NVDA database, you'll be able to find all the vulnerabilities. I think you've seen something like CVE 2023, CVE 2024. Now the 2024 are the ones that have been discovered in 2024. So if you can just continue reading through, then some of the things is subscriptions. If you subscribe to, let's say, if you write Spring Boot, and you subscribe to some of the Spring Boot forums, whenever something pops up, they will definitely be there to advise you on otherwise, right? Same case to, I think, we have a WAF. The WAF is Wallam. So it also has a place where they publish any new findings, and they also aggregate any new findings. So then in the near future, we are going to enroll on a cyber threat intelligence platform. So the cyber threat intelligence platform, it gathers data from different aspects. So, a lot of hackers currently, they use things like Tenable, they use Telegram, right? They have their Quora side channels and other platforms. So cyber threat intelligence goes and gathers intelligence from these conversations. What's actually going on? What are the hackers talking about? And they curate that information for you to ingest. So if you can have a platform that is giving you intelligence, you will be forever ahead or at par. Actually, you'll be at par with what they're doing because it's gathering information about their discussions. So you will be maybe a minute late or two, but at least you know what is going on out there.
All right, that's really great. Okay, so opening to the audience again. Let's see, you have a lot of questions, guys. Right? So this is the time for you.
We had our first
where am I
question.
going still?
No, I think he carried up his hand first.
All right.
Yeah.
So you can just have the mic. Yes. Nice.
Hello.
Hi.
Hello.
Yeah, my name is Foster. I'm a DevOps engineer at the Mountain. So my question is going to back to the dependencies. So let me use the example to clarify my question. So for example, we are going to start a project, do it in waterfall, we do all the features together. So we scan everything, it's fine, put it in production. So then as time passes, one of the dependencies becomes vulnerable. So then either it's in production, we are monitoring everything, either the host on Irembo or Datadog. So then that dependency becomes vulnerable. What is the best approach to avoid that never happening?
Wait, let me see. To avoid dependencies from getting vulnerable in production.
Yeah, no. So you say it's become vulnerable, but once dependencies become vulnerable, there's any other alternative. So what is the best approach we can use to avoid that to happen? Once we get that dependency vulnerable in the production, so we get to know that as soon as possible to avoid to know that
Later.
Yeah.
All right. Awesome. Yeah, that's a great question actually, and that's why we employ observability. We have our site reliability engineer here who is very good on that, doing the monitoring and everything. And again, it will come back to the tools. So I think I mentioned the tool that we are currently using called KubeClarity. It's open source. So if you have KubeClarity, Kubernetes, it runs in Kubernetes. You deploy it using Helm. It's very well documented. The tool just sits on your infrastructure and it just goes through. It scans. You set how often it should be running the scans, and it will automatically pick up when the vulnerability arises. We have also another tool for us internally. We use New Relic, where we have enabled vulnerability management on that. So in that aspect, New Relic also it's an agent that is seated with the code, within the code. It's something that you have to embed on your dependencies. And it just runs, as the application is running, it also runs. And whenever it detects any vulnerability, you can set a trigger or an alert. Whenever something comes up, it should maybe send that to Slack or raise that with your incident team. So the monitoring aspect will come, it depends on how you configure your monitoring tools. You configure it such that when something comes up, you get your thing. But also something that we do internally is we do an assessment each and every quarter. So by an assessment, because we have application security engineers within the organization, so this quarter what they will do is they will start, I spoke about complementing a tool. So SonarQube is a manual tool, SonarCloud is automated. So we will take SonarQube and complement the results with SonarCloud. We will take the OWASP dependency checker and complement the results to the New Relic. So that way, if one tool misses, at least we know that within 3 months we should be able to catch it with the other tool. So that's something else that you can employ.
All right, so who's next? Yes, you can. No, that's all.
Good afternoon. My name is Blair. I'm a student at Carnegie Mellon University. My question, if it's not a secret, what are some of the challenges or problems you faced while implementing DevSecOps, and how did you overcome them or mitigate them from happening in the future? Thank you.
Yeah, that's a good one, because I think it relates to what Peter had just asked. Definitely when you bring these kind of limitations, the software team, they have deadlines. And then you're like, no, you cannot go on until this is fixed. So definitely it will come from your management part of view. I think it comes from the governance. So from the governance perspective, so this is where you're engaging your senior management. So we all report to the Chief Product and Technology Officer. You very well tell him what will happen if this thing goes on. Then if he agrees, definitely security here is a no-brainer. So he will definitely agree. And then he's the one who will help me talk to the developers so that they can prioritize them. So that's how we work. We also have, like a tracking system. Because it's one thing reporting, it's another tracking whether it was fixed or not. So you report it, you put it on Jira, and then you're able to follow along. And also we have something called OKRs, key results. So that particular task is assigned to someone as a key result. So because of that, because he will be evaluated or she will be evaluated if they fix the issue that was reported and fixed on time, then that will again help. So definitely if it can be a top-down approach and also an east-west approach, where you have the support at the higher level, and also you guys among yourselves you're able to communicate maturely, because there's some people who will just be like no, without listening to the explanations that you have, and you also have to understand their scenario. There's something that they need to push past. You just have to have a conversation around them. But yeah, that's it. The top down and the east-west conversations that must happen. And the tracking system should also be there. You report something, and visibility also. The tracking system should be visible to everyone, such that the transparency, you don't have to be the one following up on everything. Yeah.
Yes, there at the back. Irembo.
Wow.
Thank you very much. My name is Julien. I'm a software engineer here. My question is, with the rise of AI, so solving problems for developers, you may find a scenario where developers provide company code that are confidential. You might find you may face a problem in an environment, provide to GPT like a secret key,
Yes.
something like that. So I was asking from your point of view and as a great aspect to it, how you do that and how you think to mitigate it. Yeah.
Well, that's a good one, because we have some problems that have solutions, and we have some that are just problems as they are. And this is one of the issues that we have, not just here, but globally, where at the moment we've not walked this path before. AI is very new to a lot of people. myself included. And so we do not have any policies or anything in place to govern these. And I think we have a case, we have some few cases where some companies have actually reported that their code was found in ChatGPT. But now, how do you limit, or how do I limit you from uploading your code to ChatGPT? So these will break some, okay, just from an example that we did, is where instead of coding or instead of programming on your desktop, we provide you a virtual environment. And on the virtual environment, you cannot copy anything. So basically, what we're doing there is, in as much as we're bringing security in place, we are bringing a lot of limitations for the developers. You want to, again, copy some code from the documentation. If I go to, like, let's say, GitHub Actions, the marketplace, and I see how to deploy these, it's just copy these and paste it in your code. That's the formal documentation. Do I have, again, to manually type it? This is the actual page. Do I have to, again, force the developer to type it word by word? So that's one of the limitations that you can go in that way. So you can either use, I think, AWS provides a very good environment. Citrix can also do the same. You just configure a VDI for you, virtual desktop infrastructure, give you access to that infrastructure. Where in that infrastructure, the only thing you can do is type. And also in that infrastructure, I can be able to control the links that you can browse. So I will just enable GitHub. So that means you cannot in that infrastructure, if you want to access ChatGPT, you won't be able to do so. If you want to access Gemini, you won't be able to do that. If you want to access any other website, you won't be able to do that. So that's one of the ways to go about it. But again, you also have to compare. Is the solution worse than the problem? That's also something else you have to compare. Is that?
Alright, so let's have the last question. Yes, from the audience. It's okay. Here in the middle. Yes.
We can take the last two also. Last three.
Let's take the last one.
Okay.
Okay, right.
So, thank you. My name is Tom Amandala, and I'm a software developer. So my question is, what are the factors to consider when choosing those tools that you just taught us? Say, for example, for new companies who wants to start implementing their DevSecOps.
I see.
Thank you.
All right. Also, I think that's a good question. So it's what to consider before you even delve into these tools. My opinion in this case, I could be wrong, is what's the problem that you want to solve? Understanding your problem first. Is it, and also understanding your processes. What processes do you have in place? In terms of, let's say, like on the CI/CD, what processes are there? If I write code, am I the one who should merge it automatically, or should someone else review it? Should I merge it on the main branch that is going to production? Those are some of the processes that you need to first align on. Then after that, you start from the simplest way. I think Occam's razor, everything should be simple and not simpler. You first start with the open source tools because one, these things do not incur any cost. So you're in a position now to start accumulating your data. So now once you start with open source, again, you continue expounding on your problem, understanding your problem, and gathering data. So if I use an open source tool, I will be able to say how long it took me to configure, to follow up, and everything else. And then I will be in a position to show the number of vulnerabilities it caught, or it kind of identified, and everything else. So whenever I'm going to request for a budget, because some of these security tools can be somewhat expensive, you have what it takes to defend your request. So you will have, in terms of time, how much it takes, the benefits, because now you'll show it with the number of vulnerabilities you've identified and everything else. And then now you'll be in a position you have already understood your problem, which gives you more, because you've been involving in the community. Open source has a lot of community. And once you're reading through documentation, it kind of points you to various tools. So now you've already identified the various tools that you might use. So with all that information, you're in a better place now to go commercial. But diving right commercial, then later on you realize that that's not the actual problem you were supposed to solve, or it will take you 6 months to put your processes in a row for that tool to actually be beneficial to you. You see, you've lost 6 months of your license and you've paid for it. So I think the other approach would be best.
All right, that's really great. Yes, the last question from my side, as we are just winding up, there might be like somebody who is just following us, and maybe he owns a software development company, and he wants to start implementing the DevSecOps. And some of the security tools that we see that we just use when in the CI/CD pipeline, they're like the standard tools, right? So is it able to re-engineer this process, maybe before allowing the code to go in production? You just want to check if, for example, like admin endpoints are not opened. So is that really possible? Is it really able to, Yes.
Awesome. So the question is it able to identify issues on the API level?
Yeah, something like that. Yes.
Okay, awesome. So I think something that we didn't cover, we covered the static application security testing. There is something called dynamic application security testing. So this dynamic application security testing is ran after the deployment happens. So the application is already live. So what you want to do is you want to run a tool, maybe authenticated in one way or another. It will go through all your APIs, and then now it will be able to tell you whether there is any data leakage in there, or whatever you're looking for. Is this API, can it lead to, how do we call these things? Something like, what can happen on the API level? Local file inclusion.
Data mining.
Is there any, the data leakage perspective? Is it, I think, Bola, where you're, is it idle, where you're able to, sorry? So there's a lot of issues that you can find from that. Also, internally, we use a tool called Tenable. It's it's a tool that if you just Google, so you can be able to configure API scans. So basically, this is where you just take your entire Swagger file, you give it to the tool, and then you give it some credentials to that application. So whenever a deployment is done, for us, we run them weekly on Fridays. So on Friday at 9 p.m., you find the scan running. So it will just go through all the APIs and try to identify whether we have any vulnerabilities in there. Alternatively, you can employ something like a WAF. If you have the ability to apply a WAF that is AI enabled. So basically, this WAF is just monitoring the traffic that comes in and out, learning, and then after it learns, it goes now to the blocking mode. So if I'm used to a username being ABC and then the password being 123, those are not good passwords, sorry for that. So whenever it sees someone who is trying to, a SQL query on the username level, it has already learned and it has the AI capabilities. It will be able to block that for you. So you can see the tools can automatically block that for you. And they're there to give you more insights.
Oh, that's really great. Another round of applause, please. I think this was really great. I think, if everyone who has some questions, I think most of the questions were answered. Yeah, right? Okay, great. So as we're winding up, I'm going to call upon Chen. He's the head of product and engineering here at Irembo, and tell us something. Thank you very much.
Awesome. Good afternoon or good evening, everyone. So I just want to thank you for coming. I hope that you enjoyed the talk, the insights and everything. And the only thing that I would add is that Irembo security is really part of our culture. So, and the best way to do it, as you might have realized, is to have security by design, right? If you have security as an afterthought, you are going to pay the price of it, right? Either by productivity of engineers, either by leaks that can happen. So you have to have security by design, and we have implemented a few practices here. I think like Geoffrey mentioned some of them that we have at Irembo. But generally, I hope that you learned something. That's the objective of this talk, that you learned something new. So you will leave this office with something new that you can apply in your own development journey to better integrate security in the life cycle of your application. So thank you very much for coming, and happy networking. Thank you very much.
Yes, everybody, thank you all for coming once again. These Tech Talks are recurring every 3 months, so keep an eye out for the next Tech Talk. Please make sure to follow us on Spotify as well. There will be a podcast version of this as well as the first edition of the podcast. I want to announce that there are refreshments and snacks downstairs in our kitchen. If you want to have a little bite and network a little bit, please be our guest downstairs. You will find the kitchen under here, right there. Go down the stairs. Yes. DJ, you can play some music.
Thank you very much for attending.
All right, thanks.